Okay.
More to you.
So, just to underline that point, Salvatore had that nice picture of the hotel, modern hotel in North Korea, as a symbol of the nightmare for infrastructure providers, namely it's not used. So we're trying, and Ross I think also mentioned that, so what we're trying to do is to avoid that by making sure that we are closely tied together with, closely tied between the services and the users. So this is a quote from Nellie Cruz. I think actually Mirko stole this line from me, but so these are the qualities that make gold precious, but data is precious in many ways for really very different reasons. And it's this thing about combining the data together that's really critical for what we want to do, because it's also tied together with value of data. If we were just preserving the bits, then we wouldn't really be adding value. To preserve and facilitate the combining of data is what I think we are really attempting to do, and that's tied in with the building of the Earth science community from the various members of the SCIDIP-es consortium, from Earth observation, volcanology and so forth. So the reason we have to do anything is that things change. I mean, if things didn't change, we wouldn't really have much of a bother about digital preservation. But technology, of course, the hardware and software, the environment, in the sense of, schemas for ontologies, things that we rely on that are out there on the internet, and quite tricky is this tacit knowledge of users, but that's kind of a key to making the data more valuable, because what we're doing is to follow OAIS to focus quite a bit on identifying this, because if you can tie in your preservation activities to who's going to be using the data, it's then much easier to make your data usable to other communities. So that's quite an important point. Now, what is the mantra that you often hear is emulate or migrate. That's the sort of standard thing. But for data, I think that only really works in special cases, for the reason that you're kind of locked into what was done before, but you can't combine things. You can't combine that old data with the newer data. You can't use the most up-to-date tools. And in particular, it wouldn't really help in building that cross-disciplinary earth science community in SCIDIP-es. So, as Mirko said, numbers. But even here, of course, even if this is a simple spreadsheet, what are the you need to know things like what the units are. What do these mean? How is it measured? Time. Well, that's obviously just a date, but I imagine there are other characters on the end there. But is that GMT, universal time? Does it have leap seconds taken into account, which can be quite important for scientific data? Is it satellite time? Is it GPS time? Time is not a simple thing, as any astronomer will tell you, and you really have to tie that down. Just as an example, you need to add the meaning to those numbers. Just preserving the numbers isn't enough, and you need to be able to understand that data well enough to process it, combine it with other sources of information to produce things like this. So what we're doing is to recast that emulate or migrate to say we need to, in order to get preservation and reuse, you need to think about what OAIS calls representation information, and that includes emulators and all of those sorts of things, or you transform, or, and this is the something I'll be coming back to, or this is something that repository managers do not like to think about. That is, it may just be that your repository can no longer take care of the data, in which case you have to face the fact that you need to move over to another repository. And that, from past experience, can actually be quite difficult, because repositories have their own naming conventions, the way they store the provenance, it might be completely different from one system to another. The pieces of information may be split across different internal systems, and just to imagine taking that out and giving it to somebody else, you can end up either spending a huge amount of effort to do it properly, and if you're spending a huge amount of effort at the end of the repository, you're likely to mess up, because not least people will depart, leave your repository if it's about to shut down. So the likelihood is, if you don't make preparations, you'll end up with a big mess, and the data will not be preserved. So representation, information, or transform, or be prepared to move. So that's the thing. So just an example of representation information. This is a particular Earth observation data file. In order to understand that, one might say, well, you need the format. Okay, so there's the file standard, but that might be described in a PDF file, which at the moment is fine, no problems. But in future, you might need to take account that the PDF might no longer be available. But that isn't enough, because normally in any of these files, whether it's a TIFF or anything else, you can add all sorts of things in the headers. And normally there are a few things defined by the standard, but certainly in science data you tend to, the standard might define 10 or so normal keywords. The actual file might have 300. So what do they mean? So you need a dictionary. Now the dictionary may be a simple text file, but it may need to be specified, because it might be something in XML that's machine readable with a certain schema, and you need to know, how to deal with that, and what the XML tags mean. But you also might do something, not just describe the standard like this, but describe it more formally, using some sort of file description language. And of course you do need to know these other things as well in order to understand and use that data file. But what you need to give to a user depends on what that user knows. So in other words, the current ESA users of this data, you just give them the data. They don't need anything else. But if you want somebody else to be able to use that data, then you need to give them rather more. And the amount that you need to give them depends on their sort of baseline knowledge of this area. And ultimately, if you want to be able to have non-Earth science people understand this, you need to provide, or be ready to provide, a whole lot of basic information about Earth science. So transformation, you can change the format. These are fairly normal things, but what one finds, especially for scientific data, is, okay, the structure changes, the format, but the semantics, it may change or it may not, and that's something which may or may not keep things easier, or make things easier. But just to be clear, what we're doing in this project is not to, as I guess maybe SCIDIP, you'll hear about later, is thinking about, I believe, and that is, the wherewithal to do these sorts of transformations. We're not doing that. We're going to help make the decision as to whether that transformation is needed, and the tools to create that basically representation information about the new the new file. In terms of handover, what I've mentioned these issues before. Now, what we're trying to do here is to enable repository managers to create what OAIS calls archival information packages. So this is not to completely change everything that they do, because that would be insane. It's instead to provide, and all of these services and tools sit on top of what the repository already has. So the idea is to supplement what repositories do, not to throw out what they do and get them to repackage everything. So these can be done in quite lightweight ways, but which if you capture now, while you've got the staff and the expertise, will make the handover of that data to any other repository much easier, because it forces you to think about these system dependent things and allows you to pull out all of those things in a good way. So things change, so we need to know things have changed. So repository managers are usually smart people, but they don't know everything. So we're providing what we call an orchestration or brokerage service just to allow people to exchange information about what's happening. But then there are implications of those changes, and that can be quite a complex thing to analyze, which again, repository managers may or may not be in a good position to do. So we're providing a service that will help think about or identify the implications. Then of course, things have changed. You need to do something. So a preservation strategy toolkit allows you to identify costs and risks and evaluate the different alternatives before actually going into it. And this is the full sort of OAIS analysis, again thinking about representation information and those sorts of things. So in particular, if you do need representation information, then of course it would be nice not to have to create everything from scratch. So a registry service of representation information is something we'll provide so that we can, so that the effort can be shared. If there's a transformation, one of the tricky things, which science repositories tend not to bother about too much because there's so much trust around, but I think it's, especially in the climate change area, it's really getting to be quite a big point of debate, is how do you maintain authenticity, the evidence for authenticity. So we've done quite a lot of work on authenticity before, and we'll be providing a toolkit to help identify what needs to be captured in order to have convincing evidence. Alternatively, hand over to another repository. So we define a storage service which really sits on top of an existing repository, but allows the data manager to capture, while it's convenient, all of the information that's needed, and in a sense make the repository look as if it has archival information packages in there rather than all sorts of different pieces of information. And of course, to make sure that the data continues to be usable, we're doing things in terms of representation information, but thinking in terms of virtualization. How do you get this piece of data, which is normally dealt with this piece of software, how can that be more easily used in somebody else's software that looks at data rather differently? So we're trying to make it easy to, for example, say, well, this is the way. If you want to look at this data as an image, then this is how you do it, and then it's easier to plug into other tools. So one key question is, I mean, we're making these claims. Everybody else that you see here makes claims about what's happening, or rather the goodness of their tools, and you should use this. So we were quite keen to provide the rationale for why we think these services satisfy general demand, because we are aiming at something quite generic. We are tailoring it to the earth sciences in order to make sure we have at least the first community of users, but it can then be the services can then be tailored to other communities. So how does it satisfy, does it really satisfy a genuine general demand, and does it actually help with preservation? Because that's quite a key thing. Because if you get that wrong, if you're doing stuff that doesn't actually help, then in 10 years' time, a lot of people will be cursing you. So we have what we've done is to collect over a number of projects some evidence. So PARS Insight is something that's been mentioned. This shows some of the, I think these are the research responders from around the globe, different colours of different disciplines. So quite a wide capture of information, and it was several thousand responses. I guess if you add the various pieces together, it's about 5,000 responses to quite lengthy questionnaires. So we're very lucky in that, mostly in Europe, a lot in the States, and then about a quarter in the rest of the world, and covering many, many disciplines. So some of the key questions are, what are the main threats? So I hope you can see these colours, but this is the 50% mark. So as long as these two colours together go beyond 50%, then that means that they think these threats are really important to their data. So I won't go through them in detail, but just to illustrate, we have the numbers to just break this down by discipline. So you can say, well, are the technologists or the social sciences any different from from agriculture and nutrition? Well, the answer is actually, surprisingly, no, because this is one particular question broken down. So the sort of error bars on here are probably, that sort of wide, but it's clear that they're all pretty consistent in giving responses to recognition of these particular threats. And that gives us yet more confidence that what we're talking about satisfies a general need if we address those threats. So this is how we've analysed it. Again, I won't go through this in detail, I don't have time, but if you read the documents of the project, you'll see this. And so we've analysed the threats. These are the sort of fairly general statement of requirements for solutions, and for each of these, or most of these, we have tools or services which counter those threats. And that's why we think that what we're doing satisfies a general demand. And so I've mentioned PARS Insight. Caspar is another thing that we build on. And one of the things that we did in Caspar was prototype these services and produce evidence. So these are some of the threats, and this is various sorts of science, cultural heritage, some very strange artistic endeavours, and for each of these we had a test case. We simulated accelerated lifetimes, changes of hardware, software, environment, legal environment also, and authenticity and so forth. So we've got not a full coverage, but a reasonable coverage of evidence that what we're doing, the solutions to these threats, actually work. So, and that's the basis on which we make claims about the goodness of these services. So these are all of the services here: the registry, the gap identification, orchestration, and storage. Now these, we call them services because we imagine them running on remote servers, because that's the way you can share the information. But of course you could run one of these locally, and the toolkits these tend to be sort of fairly generic. They're just dealing in kind of blobs or identifiers. All the details are handled by the toolkits, which can be very discipline specific, some reasonably general, and they would tend to run on local machines. This would be what the local, what a person would use to create some representation information and so forth. And we use other things out there like the various certification and persistent identifier services. And this I will be taking from the APA2012 project, which you might hear about later. And again, you won't be able to see that, but what it says is these supplement what repositories do, customized for the different repositories, make it easier for repositories to do preservation, essentially by sharing the effort. So doing it better and hopefully cheaper by sharing the effort. So I just wanted to illustrate one thing, and that is that what we're doing with the preservation strategy toolkit is, look, there are various options when you do these things as to how you describe the data. So what we're trying to do is to look at the different options by providing tools to draw these things out, picking up information from registries, then identify costs and risks, allowing the repository to balance things, because they might want to reduce the risk to zero, but that could be extremely expensive. So therefore, they have the opportunity to balance what they have the appetite for, I guess, and so that we tend to call a preservation network model. And one of the options which isn't shown there is to transform the data to something else. And this is a distributed system. I won't talk about that. There's no single point of failure and so forth. Although the APA will tend to run a sort of a service which is there if all else fails. But clearly, what we rely on is being usable and used by the earth science community, and that will guarantee the maintenance of this software long beyond the SCIDIP-es project. And just tying back in with what Mirko said, besides just making sure we tailor our services to the earth science community, we're also trying to build that community in the sense of avoiding a sort of Tower of Babel by allowing people to see what others are doing in terms of how they're describing data, because although we have to, in principle, be able to manage enormous diversity, and that's how we're designing it, yet we would prefer, in the interests of usability across disciplines, to manage that diversity. So I'll hand over now to Ugo to talk about some more details of the user requirements capture. Thanks, Ugo.